I am Dr. Lutzmary, Associate Professor in the Department of Computer Science and Engineering, Rohini College of Engineering and Technology. I am going to take subject computer operating system. The subject code is CS849. The topic I am going to take is the basic concepts of directory system and allocation methods in operating system. Under this, we are going to see the free space management. So grouping is modified link list to store address of next n-1 free blocks in first free block plus a monitor to the pointer to the next block that contain the free block pointers. So counting, because space is frequently contagiously used and freed with a contiguous allocation, it extends or clustering. It keeps address of the first free block on count of the following free blocks. Free space list then has entries containing the addresses and so use space maps using ZFS zone free space. So consider the metadata. So metadata is nothing but data about the data on a very large file system. Full data structures like bitmaps couldn't fit in memory. So divide device space into meta slab units and manages the meta slabs. So given volume can contain hundreds of meta slabs. Meta slab has associated space map. It uses counting algorithm but records to log file rather than the file system. Log of all block activity in order for the counting format. So it replay log into that structure, combine contiguous free blocks into single. Efficiency and performance. Efficiency depends upon disk allocation and directory algorithms. It's a type of data keep in files directory entry. Pre-allocation or as needed allocation of metadata structures. Fixed size or varying size structures. Efficiency and performance. The performance will be keeping data and metadata have to be close together. So can have the buffer cache and it will be having the storage. So this is for fast access. Cache will be the smallest fastest memory. So it have the look-aside buffer, separate section of main memory for frequently used blocks. Synchronous writes sometimes requested by apps are needed by the operating system. No buffering or caching. Writes must hit disk before acknowledgement. Asynchronous writes more common, bufferable and faster. Free behind and read ahead techniques to optimize sequential access. It reads frequently slower than writes. Page cache. It caches pages rather than disk blocks using virtual memory techniques and addresses. Memory mapped I/O uses a page cap. So routine input output through the file system uses the buffer cache or the disk cache. This leads to an I/O with a unified buffer cache. You will be having the buffer cache. It's a page cache. It will be using memory mapped I/O using read and write. The file system will have the buffer cache. That will have the page cache and it will be using memory map. So unified buffer cache, it uses the same page cache to catch both memory mapped pages and ordinary file system to avoid double caching. We should not have the double entry. Then the redundancy causes, it reduces the fastness of the data, which caches the gate priority replacement algorithm has to use. So buffer cache, you can have the memory mapped I/O and I/O using read. So recovery, how to check the consistency, compares the data and architecture with the data blocks on disk and tries to fix the inconsistencies. Can be slow and sometimes fails. It uses system programs to back up data from disk to another storage. Example, magnetic tape, magnetic disk and or optical disk. So then recover lost file or disk by restoring data from the backup. So possible question, consider a file system where a file can be deleted and disk space reclaimed while the links to that file still exist. So what problems may occur if a new file is created in the same storage area and with the same absolute path name? How these problems can be avoided? Thank you. Thanks for your patience listening.